Understanding potential transformers, often referred to as PTS, and current transformers, often referred to as CTS, is essential when working with primary switchgear at medium to high voltages. These devices are crucial for safe and reliable operation, and they play a vital role in control circuits for breaker operation. Let's delve into how they function. First, consider potential transformers. Their main function is to reduce high voltage levels to safer, more manageable levels suitable for metering and control circuits. Think of them as voltage step-down transformers specifically designed for instrumentation. They connect across the voltage source, such as a busbar in the switchgear. This connection allows them to provide an insulated and scaled-down representation of the voltage present. This scaled-down voltage can then be safely used by protective relays, meters, and other control devices. Now let's look at current transformers. These devices perform a similar function but for current. Current transformers reduce high current levels to safer levels that can be used by metering and control circuits. Instead of connecting across a voltage source, the primary conductor carrying the high current passes through the current transformer. This current induces a current in the secondary winding of the current transformer. The secondary winding then provides an insulated and scaled-down representation of the primary current. Just like with potential transformers, this scaled-down current is used by protective relays, meters, and other control equipment. So, how do these transformers work with control circuits for breaker operation? Let's start with potential transformers. Potential transformers provide a voltage source to the trip coils in circuit breakers. These trip coils are responsible for opening the breaker during a fault condition. Normally, the potential transformer provides voltage to the trip coil, but when the voltage drops below a certain threshold, which might happen during a fault such as a short circuit, the trip coil is de-energized. This de-energization then triggers the breaker to open, isolating the faulted circuit. Next, consider current transformers. Current transformers provide a current signal to relaying devices that are designed to detect faults. The relaying device continuously monitors the current signal from the current transformer. When the current exceeds a predetermined level, indicating a potential fault or overload, the relay sends a signal to the circuit breaker. This signal instructs the breaker to open, thus interrupting the flow of current and protecting the equipment and personnel from the fault. The accuracy of both potential transformers and current transformers is extremely important for proper circuit protection. If the transformers are not accurately scaling down the voltage or current, the protective relays may not operate correctly, which can lead to damage or even hazardous conditions. Maintenance and calibration of potential transformers and current transformers are essential to ensure their continued functionality. Regular testing and inspection can help identify any potential problems before they lead to a failure. This includes checking the insulation, verifying the turns ratio, and confirming the accuracy of the output signals. These tests ensure that the transformers continue to provide accurate and reliable data to the protective relays and control circuits.